Okay, so here, I think this is going to work. So here's question number 23 out of section 6.4. And the question is some video, I don't know if it's mine or not, what the professor did to solve this equation. I guess what they did is they did sine, and then they dropped in a u here, if I understand this correctly. So the reason they did that is, or if I did it, the reason I might have done it that way is to just make it a simpler question for now. Now, what some things we have to keep in mind is that number in front of that theta, the variable, changes the change of the period, right? Normally sine and cosine functions have a period of 2 pi. So by dividing by 2, which would be the period, new period, it shrinks it to that's where they got pi from for the b number. Remember b equals 2 pi divided by the period for sine and cosine. So so I'm working backwards a little bit. So this is going to repeat more often, every 2 units rather than every 6.28 units. So it's shrinking it up. You can't see my hand, can you? Rather than shrinking it up horizontally, horizontal compression. Or is it? Yeah, some horizontal compression. So what we're going to do is we're going to solve it now with the u in there momentarily. So I'm going to divide both sides by 2. So I've got sine of u equals 1/2, and then ask myself, when's the sine equal to positive 1/2? Well, on the unit circle, sine is positive in quadrant 1, and it's positive in quadrant 2. So if this is 1, this is 2, that's going to be actually, if you look at the unit circle, you'll see that this is pi over 6. And because it's in quadrant 2, the reference angle is the same, pi over 6. So you'll see here, let me get a different color ink going here for the second angle. And then we'll also see this angle here, which is 5 pi over 6. Here, how do I undo this? Companies change apps. Right, and I don't want to listen to rave on about that. Let's see. So 5 over 6 pi is what that other angle is. So they're looking for, there's 2 answers, but the trouble is that's when the period is 2 pi. So what we've done is we said, well, u equals, or let me go back to a darker color here. So we can say u equals pi over 6 plus, and then to get there, we're going to go all the way around because we're looking for all salaries, right? To get back there, we're going to go all the way around the circle, however many times we want to go around. And then the other one, we can say u equals 5 pi over 6 plus 2 pi k. And then what they did is instead of u, we lost that pi theta here. So we're going to include that back in. Oh, here's the eraser. So I'm going to erase the u's, and I'm going to write back in pi times theta and pi times theta. So I'm going to divide both sides by pi. On this side, I'm going to write it as multiplying by 1 over pi, because that lets me see I'm going to distribute. So that makes this side be 1 over 6. So because the pi's cancel out, right? 1 over pi and times 1 over pi. So the pi's cancel out in each case. So 1, 6 plus 2k. So you see how we're getting that period of 2 in our equation or in the answers. And the same deal here. We're going to divide by pi on both sides. So we multiply by 1 over pi. And that gives me 5, 6 plus 2k. And that's how you find the 2 solutions. Now, you don't have to do that u substitution. If you're okay working with that expression right there, I mean, do it. I rarely do that change anymore. I just usually work with what's there. Let's see. Can I add a new screen from this page, or a new or I got to delete everything? I don't know. Let me play with it and see. Try. No. I guess I'm just going to try to delete everything and see what happens. It worked pretty well. Okay, so I wrote down another one. I wrote down number 40. Looks like it's a little bit different because well, what's different about it's not a unit circle question, so that makes it a little more challenging. So 3 cosine of pi over 2x equals negative 2/3. So if we want, we can do that u substitution. Maybe we should. So u equals pi over 2 x. So I'm going to rewrite this equation. Can I make this jump? Can I write, I'm going to divide both sides by 3, right? So I'm going to get the cosine of some angle u is equal to negative 3 over 2. Well, that's not a unit circle question. So we have to do the arc sine of that. And I don't have a calculator right on me. Just let me pause my video. Let me pause my recording and I'll come back. Okay, so I'm going to come back to my whiteboard. And so I'm going to calculate, I'm going to do arc sine or second sine of negative 2 divided by 3. I'm in radian mode. And my calculator is telling me 2.3005. I'm going to round that to 2.3. So U equals 2.3 radians. Now, what we got to think about it when we're looking for all, and this is just solutions. This is the first two positive solutions, I think, is what they said. So we still have to deal with that pi over 2x. Cosine is negative over here in quadrant 2, and it's also negative down here in quadrant 3. So here's one angle. And Dan LeMay, what you doing here? And here's the other angle. So this angle is 2.3 radians. Now, how do I get the red angle? So my process is I'm going to find that reference angle. So I'm going to do pi, which is the full angle, right? From 0 to 180 is pi, minus 2.3. And that's going to give me pi minus 2.3. I'm getting 0.842-ish. So 0.842 is their reference angle. And that tells me this reference angle is the exact same size. So what I'm going to do is I'm going to do pi plus the 0.842. And that'll tell me that whole red angle. So I'm going to leave that. I don't have a rounded value in my calculator. I'm going to leave that. I'm just going to add pi to it. It might be a little bit different. I mean, if it were just me doing this on paper, I guess it is just me doing it on paper from this book. So I'm not trying to make my open math happy. So this red angle here, let me get fancy and change it to red. I hope nobody who's watching this is red, green, colorblind. I'm sorry if you are. My son is, so I'm conscious of that. 3.983, I'm going to write. Okay, so that leaves me, I know that U equals 3.983. And I know that U equals that 2.3. Now, they aren't asking me for all solutions, so I'm not going to write the plus 2 pi k. I could, it wouldn't be wrong to. I just don't think I need to do that for this question since the book is only looking for 2 solutions. So U, and I'm going to do that back substitution. I'm going to say pi over 2x is U. And I won't go red here. I'll just go pi over 2x equals 3.983. So we're going to divide both sides by pi over 2 or multiply by 2 over pi. The reciprocal, right? I won't show it on the other side. So to get those first 2 positive answers, I'm just going to take 2.3 times 2 divided by pi, and I'm getting 1.464. So x equals 1.464. And then the other one's going to be the 3.9 number times 2 divided by pi. Get an error here. Times 2 divided by pi. here, so I'm getting 2.536. So x equals 2.536. Now, how could you check your answer here? I mean, those are messy, awful messy numbers. How could we check our answers? Well, I'm going to write down, just in case I don't have access to this, I'm going to go open up a Desmos graph, and we're going to check that out. And let's see, I'm getting what, 1.46? Yeah, 0.464 and 2.536. All right, so here I'm gonna stop my recording or pause my record. So I went to Desmos. I put in the cosine part. On the other side of the equal sign, I put in equals -2. And now we're looking for the first two positive solutions. So there's the first one, which corresponds to my 1.46 number. And here's the second one that equals my 2.3536 number. So I did solve this correctly. Okay, so hopefully this answers your question about why are they doing that U substitution in the equations? Well, it's just a step to make it a little easier to do. It may even help when you get into section 7.1 where you're solving those quadratic equations. Do the whole U will equal the whole cosine. But you didn't ask about that, so I won't add that to this video. Let me know if you need some more help. We certainly work some more in the discussion forums, or you could join me for a Zoom session.